Salutare, bine ați venit! Întâlnirea de azi e o întâlnire combinată între Java User Group și DevOps User Group, tocmai pentru că Axel o să ne prezinte un tool scris în Java, cred, care ne ajută să facem chestii de DevOps. So, Axel, I think you will present us something in Java about DevOps.
Well, let's say we'll be talking a lot about ideas that and some techniques that I think will be the way forward in terms of deployment. So we'll see what you think of them. I certainly look forward to hear your thoughts on that. But yeah, we'll have lots in that direction, and we'll have a little bit of a demo using a tool as well. But most of it is ideas and concepts.
Okay. So, thank you, Axel, and we can start.
All right. Thank you very much. Welcome, everyone. I feel a little bit sorry to keep you all inside with fabulous weather like that outside, but well, it's just an hour, so hold on, we'll be okay. So for tonight, the next hour, so we're going to talk about immutable server generation, the new app deployment. So for me, it's something I've been involved with for quite a while. It's a space, and generally the DevOps space is something that has interested me for a long time. I've been in the industry since the end of the 90s, and I did lots of consultancy, and during that time I've been involved with many clients, many projects, and I always found that the intersection between development and operations was a place where there was a lot of efficiency that could be gained to express things nicely. So that's definitely an area I've gravitated towards over time, and yeah, so I'm actually on the road a lot at lots of different Java conferences and events. Last year I finally made it to Java 1, which was good fun to have seen once. It's a big, it's very American, but it's good fun to have seen. So that was nice. And so 5 years ago also I decided that weekends and evenings were overrated, and it's much better to spend them on an open source project. Not really. At the time I still thought, oh well, we'll just start and see what happens. And about 5 years ago, I was looking into the space of relational databases and handling schema evolution and migrating that over time. And I couldn't find a good solution at the time. So that's how Flyway was born. Who's heard of Flyway before? Just for you guys, okay, about a quarter of you. So database migration tool. I think the main point here, what I want to make just very quick is if you have a relational database, and it needs to evolve over time, use a tool to handle that for you. Flyway or something else. There is a comparison matrix on the Flyway homepage where you can pick basically the simplest tool for the job for you. So look at your project, your requirements, pick the simplest tool. Is better than no tool at all to handle that. These days, this is my company. This is BoxFuse. We'll talk a little bit about it today as part of the demo. So we'll go about that later. We do have more or less an hour ahead of us. If you have any questions, I think we actually should be all right. Just ask them at any time. I'll repeat the question for the video, and we'll kind of take it from there. I think we should be all right time-wise. So let's start, and we're going to start with a small story. It's actually a story about my living room. My girlfriend is an engineer, so she likes to play with things just like we do. Not software, but all kinds of other things, and she likes do-it-yourself projects and renovating stuff. And not too long ago, she decided that she wanted to change some things in our living room, and then she looked at these heat-producing devices that do produce a little bit of light on the side, and thought that it would be very nice to change them for something like this, where you basically have a device that produces a lot of light and a little bit of heat. Now, this is all quite nice, and we kind of discussed the different options. I, of course, went on Amazon and found something else that seemed much more exciting. I had this model here, which seemed much better, because once you actually turn it on, this is what your living room looks like, so a bit like the local discotheque. So I thought this would be a lot of fun, but she didn't quite agree with that plan. So unfortunately, we went for a more classic choice. But it doesn't really matter, because what we want to talk about here is actually not this part of the lamp. It is this little bit there. And that little bit there is the Edison screw. The Edison screw was really something, so it's been around for a long time, since over 100 years now. And for the first time, it allowed us to have a very clear interface between the electricity company and ourselves. So all of a sudden, we had a simple standards compliant interface and a contract where we basically agreed that we don't care anymore how you guys do it. As long as you give us 230 volts, 50 hertz, we're quite happy and we'll deal with that. So you guys worry about how to convert coal or wind or photons into electricity. We don't want to know anything about that. We want to make sure we can innovate and have a local discotheque in our living room if we want to. So this is basically their responsibility. That's our responsibility. They take care of the undifferentiated heavy lifting that we don't really care about. I'm not interested in knowing exactly how the wind power eventually ends up powering my lamp. I just pay for it for a price that I think is okay, and I can innovate at the top. So, if we go back to IT infrastructure, we first have to get to know each other a bit just to see where we all stand. So, who is right now on a project where all infrastructure is on-premise? So you have your own server, own data center, own everything. So we're about, okay, so it's a third of you. Who's doing co-location? So you own the server, but it's in a rack in somebody else's data center. Okay, so we've got a few people, about 20% as well. Who's got a root server somewhere? So you rent a server, maybe 50 euros a month somewhere in some data center, and that's it. Okay, so we've got another 10, 15%. And who's on the cloud today? All right, that's good. 25%, 30%, very good. So if we look at these different models and how they evolve, we kind of have to travel back in time. So we use our big time travel machine today. You wouldn't think it would be this exciting, but we're going to travel all the way back in time to the wild times of the 20th century. So we had these guys running around, but that was not all, of course. This was how we used to play music, and this was how we would rewind it. So it was pretty exciting indeed. And we had this guy. And he loved it when a plan came together. So when his plan was to get a server, this is how he would do it. He would get on the phone, the old style with the chords, they're very big, and probably had to turn to make the numbers and all that exciting stuff. And he would call his good friend Michael, and he would say, hey, Michael, I would like a server. Could you give one to me? And Michael says, sure, I can do that. And a couple of weeks later in the mail, you would receive a pizza box, and eventually you put it in the rack, you kind of screw it in, connect the network, the power, and then what? Still doesn't work. So we get back on the phone and call a young criminal from the western coast of the United States. Does everybody know this image? Yeah? Who then provides us with some criminal software, which we then install on our machine. And then from there, we start updating, patching, and eventually just kind of always keeping going from there. So if we have that, and we kind of summarize the components we have at play here. We have our software, we have our hardware, we have our data center. All of these together are really the classic on-premise model. And we have a fair number of challenges we need to master to do this successfully. The first one, of course, is just mundane things like having reliable power, networking, cooling available, but also dealing with things like physical security. When you have your own data center, you actually need to have that in place as well. You need enough physical space. Also during upgrades, because if you upgrade your storage system after a couple of years, it's not good enough to unplug all the existing storage, take it out of the rack, and then plug in the new one. You actually need to be able to run both at the same time if you don't want a whole lot of downtime. So this can be a challenge as well. And then you get all the challenges, of course, dealing with your vendors and waiting for a couple of weeks for things to arrive. You need to plan the capacity a long time in advance. You need to have the budgets ready and approved and all the financing up front. And only then do you actually get to the software side of things. And you start dealing with the OS and the patching and eventually the application and the updates. So what we have here is really a whole lot of responsibility. And at some point, some people started thinking, well, you know what's all nice and well, but I really don't want to deal with this physical cooling and security and redundant backbone connections for my networking and all. It's not really what's helping my customer. I don't want to deal with this. So we started saying, well, why don't you guys take care of that? And this is basically, we designed a standard interface, a 19-inch rack. We've got AC power and Ethernet. And as long as you kind of comply to that, I can come with my server in your rack. I have 1, 2, 4, you, whatever I have. Just kind of stick it in, and we're good to go. We're in business. And so this is basically the classic co-location model that we have. So here again, we basically shifted responsibility, and they take care of the undifferentiated heavy lifting. We don't have to worry anymore about doing all these things, about having our security guards and our fortified doors. Not our problem anymore. So what we can do here, of course, is say, well, we look at that and we think, do I even want to bother calling Michael, waiting weeks to get my servers and getting all that? And some people say, no, don't really want to do that. Why don't you guys deal with that? And this is the classic root server model, Hetzner, OVH, where you pay 50 euros a month, you get 32 gigs of RAM and 6 terabytes of storage, and it's all very nice. And you guys kind of deal with that as long as you provide me with this network adapter and x86 64-bit machines, and I'm all good. I'll give you the money, you provide me the service, and I'll pay you per month, and it's all nice and well. What we have here is, again, we have a simple standards compliant interface between the two. We kind of agree on it as both parties, and it's all nice and well. So this is really the software hardware type of interface. And this is what I would like to ask you to think about this. Could this be our industry's Edison screw? Something to think about. Because again, we want to be able to innovate where it matters for our customers, and we want to give them all the stuff we don't really care about, the undifferentiated heavy lifting. So let's move to the software side of things. Again, let's see where we all stand. So as far as automation is concerned, do you have an automated build on your projects today? Everyone? You guys all? Yes, you do? Okay. Who's got unit tests? All the hands still? Who's got a CI system up and running? What? You not? Okay, yeah, perfect. Who's got acceptance tests? Selenium, WebDriver, that type of stuff? Okay, a couple of hands are down now, but we're still doing okay at 70% maybe. Who's doing continuous deployment of code? Okay, we've got, 30% maybe left. Who also deploys database changes, configuration automatically? Got a few hands left. Very good. And who's doing automated infrastructure deployments today? Got 1, 2, 3. Perfect. Very good. Okay, so if we look at our process, we have our source control on the one end now, where we commit stuff, and then of course we want to make sure that we don't have dependencies on our local machine, or that we haven't forgotten to check in something. So we have a neutral referee, our CI system, that basically says, aha, it's nice and well that you've checked in something, but I'm going to verify and make sure it works. So the CI system pulls in the latest version of the sources, and we build them, we test them, and eventually we produce some kind of artifact. For the JVM, this would be a jar file, a WAR file, an EAR file, whatever you want to use. For other platforms, it's different things, but we produce some kind of artifact that has a number of interesting qualities. The first thing here is that we produce one immutable unit. We give it a version, and then from there on, it's not really being modified anymore. We don't go and patch it afterwards anymore. We just have one unit, and if something needs to change, we basically regenerate a new one after every commit, and then we promote it unchanged from environment to environment. Why do we want to do this? Because we want to avoid the classic mistake of basically building a separate artifact per environment so that you end up running something different in production than what you tested in test. We want to make sure we have the same. So if we look at the layers of our system, if we have our hardware at the bottom, and we have our operating system kernel on top of that, and then we have some libraries and a language runtime, JVM, something else. We've got an app server embedded or not with the application. This is basically the stack we have. And the model we described there really is mostly talking about the top two layers. But the big question here is, well, why only these two? Why aren't we doing the same for the other layers of our stack? Huh? So for that, we really have to kind of look at things that could possibly go wrong in these other layers. Now, I know this is going to be hard, but please be honest. If you've ever had the following problems, please raise your hand. So you're on some machine, but in one specific machine or environment where there is a piece of software missing somewhere, and somehow everything you tested in the other one doesn't work on this one. Come on, be honest. There's more than 2 hands here. Yes. Or, of course, you've deployed something, and unfortunately, some directory where you want to write to is, still has the wrong name, or it's still the old thing lying around. Who's had that? Almost everyone. Yes, me too, many times. Or, of course, you still have the old version with the memory leak on there and forgot to update it, and it just doesn't work. So, yes, bad luck, but yes, we've all been there as well. Of course, here, the big classic one, who hasn't got that, where you just can't write to the directory. This is actually something I saw in a taxi in Thailand last year. I thought it was fantastic. A taxi that forbids you to do Gangnam Style on board. I thought, yes, I must get this in here. But yeah, so, and of course, last but not least, port occupied, some kind of thing, your server doesn't start. Absolute classic. So, so if all these things can go wrong, then why aren't we holding our servers really, or these other layers, to the same standards as our applications? And if we see this process here, and we kind of have our delivery, our artifact producing pipeline there, and we have our target system we want to deploy on there. How do we deploy? Well, we kind of push the artifact to some artifact repository, we pull it on the other side, update the app, done. Actually, not too bad. Except, of course, reality rarely looks like this. It looks more like this, where we don't just have one machine, we have many machines in many different environments, and it all needs to happen there. So that, of course, we want to make sure that all of these are as similar as possible, because any difference is a potential source of trouble. And that's why we always want to make sure they're as aligned as possible to discover problems as soon as possible and not defer them. So this also means, of course, that this applies to all environments, including your local development environment. I think it's okay to diverge from this, but you have to be well aware of the risks that every potential difference you introduce for convenience, for performance, for other reasons, as part of your development setup is something that could fail later. If it would be absolutely identical, you would not run into problems. And so, of course, another aspect as well is that at some point, you will have the need to recreate certain machines or set up new environments for new types of testing or acceptance or whatever you have there. So it's just a reality. At some point, this needs to be taken care of. What we have here as well is, of course, everything doesn't stay static over time. This will need updating on all layers, on all machines. So who typically does this? Well, it's the job of the system administrator to make sure all machines are nicely up to date and patched and everything is okay. Now, let's turn to wisdom. Once again, we use our time machine and we go back about 100 years in time to this gentleman from the automobile industry. And he had this famous quote: if I'd asked my customers what they wanted, they would have said a faster horse. And this is exactly what we got in IT. We got a faster horse, better known as the automated sysadmin, often referred to as the chef or puppets of this world, that basically does the exact same job as the sysadmin, just a little bit more reliable, a little bit faster, a little bit less error prone. But the job it's doing is basically the same. It's aligning the different systems to to a recipe or a set of versions we want to be available there at all layers. So let's fast forward back to today, back to 2015. This is a quote from just about 18 months ago now from AWS reInvent in 2013 in Las Vegas, their big yearly conference. And you really have to let it sink in to realize the magnitude. Every day, AWS adds enough server capacity to power the whole $5 billion enterprise Amazon.com was in 2003, weekends included. Today, tomorrow, the day after, and again, and again, and again. It is really unbelievable. It's something we've never had before, and it's absolutely crazy. These days, they even source their own CPUs from Intel that nobody can buy. They even have their own networking hardware already for a couple of years. It's really incredible, the dimension this has taken. But they do bring a number of very, very interesting things to the table. It's not just size and abundance that they bring. They bring also a very clear separation between the control and the data plane. So this is really our nuclear reactor. You can, it's a good way to illustrate it, where you see the control room where they've got all the dials and they can check everything and all the monitors. And on the other side, you have all the rods in the water and the reactions taking place. And we have something similar for us, which is, of course, our console, maybe on the one end, and our running instances on the other. So, of course, the big innovation now is that this can now be driven by a machine. It's all based on APIs, so a machine can provision new capacity, and what's never been possible before, can decommission it immediately as well, so that you now have the possibility to integrate cost in your software architecture, where you can build systems that you then fire up for 3 hours a month because you do your monthly billing, and you shut them down again, and you stop paying for them. And this becomes an important consideration because it can have huge differences on your monthly bill if you put this in. So we've seen, and we've really shifted from a world of scarcity, where we have to be careful how many resources we use on-prem, to a world of abundance, where it doesn't really matter if we temporarily double our capacity and then shrink it again. Who cares? We just kind of pay for that short period, and that's it. And we've got a beautiful model with a very clean control plane, data plane split, and we can provision all that with APIs, and of course for the first time we can shut it off again and immediately stop paying for it, and never been possible before because you bought the hardware on-prem and it's a sunk cost, whereas here you kind of stop paying for it and that's it. So cost can now become an important factor in the architecture. It's really a very exciting time. And so because of that, I believe it is time to rethink the faster horse. If we start to question this part here and really say, okay, our server down there is really something, it's all nice and well, but it doesn't add a whole lot of value for my customer. It's a bit of undifferentiated heavy lifting, so let's pull out the physical server and put a virtual server back in. Now I have a number of new possibilities. The first one is, I can now start producing images of entire machines as the result of my build process. I do not need to have single artifacts here anymore. And that can then flow as before via an artifact repository and then land on my virtual hardware, so that I go from a model like this to a model like this. If I then make my machine images right, I can even run them on multiple types of virtual hardware. And I get to a world where updates at the individual instance and layer kind of disappear. They're all baked into the image, so I can promote the entire machine from environment to environment. But of course, I know you're thinking right now, we have one big problem left. The size of our machine images and the size of our network pipes are not really compatible. It is quite expensive today to archive thousands of versions of a machine image like that a year. It is very time-consuming to push a big machine image like that over the internet through our network pipes. So what can we do? Well, let's turn to wisdom once again. This is a quote. I forgot who I got it from, but I really like it. Running servers in production should be like going backpacking. You take the bare minimum with you. Anything else is going to hurt. So this is a picture I took the summer before last in the Bavarian Alps, and so we're in the morning. We're ready to go up the mountain, and these guys are coming down. So they'd walked up 1,000 meters up the mountain with a 20-liter keg of beer and the big glasses and the hammer to open the keg, and so they had drunk it all in the one night, and they were on their way back down. So the absolute most inefficient way to get up the mountain. And somehow, this is exactly how we run our service. We have a 20 megabyte application, and we'll have gigabytes of stuff in that image. And you start to think, but why? And so, if we're going to trim some of that fat, we should ask ourselves the question, well, what is really adding value to my customer, and what is just technical ceremony to keep me happy? What is really adding business value? Let's have a look. We're going to pull out our X-ray machine and look inside the machine image. We have a bunch of components in there. There are a few here. In reality, there's more. But let's analyze which is actually adding value to my customer and what is just technical ceremony. The app. Of Of course, we need that. That's what we're paid for. It's the problem is solving. But do we need compatibility with old binary formats or 32-bit architectures or all that if we're 64-bit anyway? No, can get rid of it. We'll keep our app server because we need it to run our app, but do we need man pages on a production server? I don't think so. Off they go. Has a customer ever been excited about the fact that we were running apt-get or RPM on our machines? I don't think so. Let's get rid of the package manager. We'll keep the language runtime because we need that to run the app in the app server. But if my app, for example, is written in Java, do I need a C compiler on that machine? No, off it goes. I believe that in 2015, the days of having 5 terminals open with tail-f and different log files and watching them roll by are just over. This is 20th century. Today, we have wonderful solutions that you can either build yourself with Elasticsearch, Kibana, Logstash, or you buy Splunk, or you use SaaS solutions where you basically ship your logs and they're being aggregated, indexed, backup, and they're making searchable through a nice web UI. You can define alerts on all that and all kinds of things. So I don't want log files on that instance. If I don't have my log files, do I need a VI on there? Absolutely not. Do I need all the other random utilities that are usually sitting there? No. And if I haven't got all that, do I even need to log in? Goodbye SSH. If I can't log in, do I need multiple users? No. If all the things I set out to protect simply aren't there anymore, do I need a firewall? No. Do I need multiple shells? No. Do I need drivers for 10,000 pieces of hardware when all I need to support are 2 or 3 virtual network cards? No. I'll need some libraries to run my language runtime, but many random daemons I can dispose of, and will keep the OS kernel to drive the hardware. So what we have here is really the bare minimum is actually adding value for our customer. And so we fuse all that together into what we call a bootable app. And we get into a very different world. This for the JVM, for example, with Java 8 is about 40 megs plus the size of your app, and that includes everything from the bootloader, the kernel, and everything up. So that all of a sudden, archiving a few thousand versions of this a year is not a problem anymore, and sending it through the network is something that goes very fast. So I know a number of you are thinking right now about some cases where that doesn't apply. It doesn't matter, just use it for everything else. All the modern microservice, 12-factor, stateless apps are a perfect fit for this. So let's have a look at it in practice. We'll see if Adobe bought a nice internet connection or not. We're going to put it to the test and do a quick demo. For that, I'm going to use BoxUse, my company's product. Just going to show you that.
And is your display on extended?
No, it's mirrored.
Because we're only seeing a black screen in Connect.
Okay. Just a second. Saved it. And what we're just going to share my old desktop. You never know if this starts working again. There we go. Desktop, share. All right. So here we go. So I'm just going to quickly rebuild the app. It's a small Maven Java web app. So we're just going to rebuild it. Take a couple of seconds. Here we are. And what I'm doing now is basically we're gonna take the app. We're gonna fuse it into a small image, and we're gonna start it onto a new machine on VirtualBox. So what we're going to go for now is just going to point it at the WAR file. I think that's what we have here. So we're on low resolution, so we'll have some, hold on. We have some scroll bar excitement, but it's scroll too far. It's up, 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 go up, go up, go up. What do we have? There we go. Perfect. Okay. So 3, 2, 1. Here we go. Here we go. So what is happening now is that basically there's some analysis process running where we kind of look at what kind of payload we passed in. So we say, okay, well, it's all nice and well. We've got a WAR file here. So a WAR file is a dependency on Tomcat. Tomcat is a dependency on the JVM. JVM has a dependency on C library. C library has a dependency on the Linux kernel. Linux kernel has a dependency on the bootloader. So let's do all that. And we kind of brought all these pieces together. Gonna scroll back up. And just a second. Here we are. So that took about 11 seconds here. So what you have to remember, this laptop has a native VGA connection. So it is a bit of a vintage part from 2010. On modern hardware, it's about half the time. We produced an image, about 48,000 kilobytes here, 48 megs. And we launched an instance of that on VirtualBox of the brand new image. We forwarded port 80 to port 8088 on localhost. We launched the instance. Here we see the instance booting, so we're acquiring an IP address. We kind of echo some summary of what we have on board, our WAR file and checksum, and some of the environment variables that we set. And here we're kind of booting our standard Tomcat, where it's kind of starting, and eventually it's here serving traffic. So what we can do here is just copy paste this guy. Just copy pasting it here. I'm going to go to the browser and open a new tab. And here we go. So basically, that's our brand new image. So it's an entire machine that didn't exist a few seconds ago that is now up and running on VirtualBox. And so the nice thing, of course, as I said, is being able to promote that from environment to environment unchanged. And so what we can do now is instead of running our WAR file, we can just run the image we created. Here it is, and we'll run it on our production environment. So by default, Boxus comes with 3 environments. So it's basically development on VirtualBox, test and production on AWS. So we're just going to push this guy out, the same image, out to AWS. So the first thing that's happening here is that we're basically pushing the image out to some kind of remote repository. So you can look at this as basically the equivalent of like a remote Maven repository or something you would have there. So we encrypt the image, we create a signature, we push it out, and when we kind of verify the signature on the other end, make sure it's fine. And then on AWS, we start creating some infrastructure. So we create an Elastic IP in this case. We create a new domain name that we map to the Elastic IP. And now we're basically waiting for AWS to create an AMI, so the AWS machine image format and their specific format, so that that takes on average about 30 seconds on their end to take that, to convert that. Yeah, so we had 30 seconds here, more or less. Then based on the information we analyzed from the WAR file and the ports we had available, we created a security group, some kind of external firewall for the software-defined network, and we mapped exactly onto that, so port 80 that we opened there, and we're launching an instance here. Our instance has started, it's in Frankfurt by default. It can configure that all you want. And basically now we're waiting for an HTTP 200 on that payload. So every second it's kind of performing a health check, and it's waiting for it to be healthy. So we'll see that takes a couple of seconds usually before the image really boots. So we'll see. Should be just there in a second. Let's have a look. So here we go. So our image has come up. We've received an HTTP 200. We are now remapping the new IP address of the new instance so that our Elastic IP is now replacing it. So that it will be visible from our domain name, and we're waiting for the transition. That has completed. So if we look here, we now have a new domain name with our application up and running. So it's basically the same image we had running in VirtualBox. Just copy paste this guy, open a new tab. Here we go. And it's basically our application running on AWS. The exact same image down to the last bit and byte that we had running on VirtualBox before. So what we can do, of course, is go here, and if I kind of go back, hold on, I can list the images I've got available. And so this is our one image we created before here with Java 8.45, Tomcat 8.22, and port 80 it found by default. You can configure all that, and so that's the time we generated it. And if we look at what we've got running on VirtualBox, for example, we still have one guy running here based on that image. By default, it takes the same amount of virtual CPUs as the host and a gig of RAM, but it's all configurable. And that's the URL it was running. So we can actually kill this guy here. Just going to kill the instance. Hold on, sorry. It's not going to work. I just use the app name. There we go. So we're killing it from the instance, and we're just going to kill that. And what we're going to do now is basically we're just going to push a follow-up version to see how that all works. So so let's see. Take 2. Can you see my screen? So just changing this, and we're rebuilding the app. Now, what we can do, of course, is we're going to run it locally first, see how that works. So here we go. Run this guy. We're going to get a new version because it already knows or found the other version and found a conflict, but that's okay. We're basically going through the same process quickly again. A new instance. So this is something you can run as part of your build process as well. So normally we recommend you run this as part of your regular build. So you fire up the instance before you run your integration tests, run your integration tests against it, shut it down, and then push it out. So our new instance is up and running on this port here. So let's look. There we go. That's our brand new machine. Our take 2 running there. And if we push it out, so if we I'll have to copy paste the version here because we got assigned a new version. Just a second. Just gonna copy paste this guy here. And there we go. And I'm gonna switch the environment to production. We're gonna push this guy out. So basically we still have an image running up there. So our image is still running on AWS right now, the old one. If we go back to the browser here and go to this tab, so that guy is still up and running, our old V1. So during that time, of course, now we're kind of going through the same process. So recreating an AMI should take us a couple of seconds again. Come on, AWS. They're running around, probably copying around the USB sticks and whatever they're doing there. A bit stressed probably since they know we're live. Come on, guys, you can do it. Here we go. Create another security group. And we're launching another instance. So what we're doing here, of course, is that the existing code keeps on running. We're doing blue-green deployment. So we don't affect the running instance. Start a new machine next to it. That's what we're doing here. So again, code is still running here. And just waiting for this guy. So it's waiting to boot now. So that'll be coming up in a second now. So we're still up. Looking here, it's waiting for our HTTP 200. Will come soon for the other instance to come up. And then we're going to remap the elastic IP. Come on.
Meanwhile, I have a question.
Sure.
You said that when you deploy your app, you see that your app depends on the application server.
Yes.
It depends on something. You define these dependencies somewhere, or you use, I don't know, dependencies in the system?
Well, it's in this case here, it's not defined because it's kind of known. So we know that there we go, we're live. So we know that basically a WAR file needs that and needs this chain. But per default, it takes the latest version of these dependencies. But we strongly recommend that you pin them to this exact version so that you control the update cycle. Otherwise, if we push a new version to the central repository, the next time you rebuild, it gets pulled in for you, and that's not as interesting. So we really recommend that you kind of pin the versions and then have it there. But yeah, very few components, and like you saw, it's just like 4 or 5, and that's your entire machine there. So there is no base Linux distribution or anything like that. It's basically, it's generated on the fly from nothing. We kind of just open an empty bucket, put it all in, package it up. Okay. So, all right, let's switch back to the talk. Let me go full screen again. So, what we've seen here with the blue-green deployment and the transition with zero downtime and all that, it kind of is a bit different from most of the workflows we're used to. So there are some implications about this. And the first thing is that we kind of have in a world like that, we kind of have a shift in focus, because the individual instance we used to care about so much has really been demoted a lot, because it's just kind of, it's coming, it's going. So the focus really shifts onto the service. It's the availability of the service that counts. It's being able to keep serving our customers. And whether an individual instance behind that is currently up or down doesn't matter as much. We really start treating individual instances as just disposable components. So but we really go from a world to something like this, and where we start treating our servers like cattle and not like pets. So I know we've all been done there. We've all named our servers at some point and really cared for them and made them really nice. And now, of course, it's a hard reality. We get more to a world like this, but that's still okay, because that's still fun. But of course, the hardest step is when it's time to let go, and then we end up with this instead. So that's that's just the reality things are, because for a long time we used to pride ourselves with the fact that high uptime was something fantastic. Like, I haven't rebooted this machine in 2 years. It's great. And the problem is, it's actually not that great, because the longer an instance is up, the harder it becomes to recreate it exactly the way it was. And the hard news is it will fail eventually. Whether it's software, it's hardware, there will come a time when you will need to recreate it, and that just makes it a whole lot harder the longer it's been up. So very long uptime is actually not an asset. It's a liability. So if our stuff is coming and going, where do I know where it is? How do I discover where my service is currently running if my instances kind of are so volatile? The answer there is really to look for a stable entry point with an internal registry. So what we saw here in the demo, for example, was an elastic IP. It's always the same elastic IP. And behind the scenes, the Amazon infrastructure is keeping track of which backend instance to forward the request to. If you want more than one instance, you can use something like an elastic load balancer, where basically the address of the load balancer doesn't change. You can always point to it, and the load balancer itself worries about where to send the request. You do not have to worry about which instances currently are up and which ones are coming and going. Not your problem. You just send it to the elastic load balancer, and it deals with the rest. So security, for me, there it's really we could phrase the question differently and ask, well, when was the last time your toaster got hacked? Because we have now a very, very different model here. We have reduced the attack surface to really the smallest possible thing that could be. But that's not the only thing. Even if you do get attacked and you do get Trojanized, because the lifetime of these instances is so much shorter, even if somebody managed to plan something there, it gets discarded at the next deployment and you start fresh. You've got a new one coming up. But even during that short time window, the potential to exploit it is also much reduced, because all the tools you would normally use to then further penetrate other nodes on your network simply aren't there. So you get in and can't do anything. Bad luck. So yes. So that's a very, very different world. The other thing, of course, is configuration. Now, configuration, I'm a strong proponent of really going down the route of baking as much configuration as possible for all environments directly in the instance, in the image, and then deciding at runtime based on some automated environment detection which one to pull out of that. But sometimes it's not doable, or there are some parts you do not want in there for some reasons, like some passwords or some other sensitive things or things you don't know at the time you create your image. So what you can do there is basically use what every virtualization solution offers you today, is the possibility to pass in a bit of textual data. And you can use that to basically pass in stuff that you can then expose, key value pairs you can expose as environment variables, and then your code can kind of read out of that and react accordingly. And this could be, this is the URL of the database you should connect to, or simply your environment is QA, so please load your internal configuration for QA and behave properly in that environment. Now the database, of course, we receive things come and go. We cannot have a long-term persistent state on these instances. It needs to be somewhere else. So this is just as it's always been. You can connect to a database server out there, either build it yourself, or you can use some of the fantastic hosted solutions for that. So Amazon RDS or Google Cloud SQL are very good, but you can just build it yourself as well. And they're I personally have been using Google RDS Postgres for a long time, and you just click a checkbox and you get geographically redundant with hot standbys set up, and it's really, really convenient. So they get good solutions there. And of course, if you need to update it at some point, evolve the schema, use a tool. I have a strong suggestion, which one that may be, but use a tool. It's better than no tool at all for that. So the logs, we already briefly touched upon this. And the logs in 2015, tail-f of your different instances, that's part of the past. So today we want a centralized logging server where we can really ship the logs to in real time. So what we want here is a place where they can be aggregated, and they can be stored and backed and indexed and made searchable through a nice web UI. So that's really what we want there. You can build your own with Elasticsearch, Kibana, Logstash. You can use things like Splunk, but if you're using some high-level languages like Java or some other frameworks, they are fantastic solutions. For example, Logly, log entries, and Papertrail. What they do, for example, for the JVM is you get integration with Log4j and Logbag, and they will literally provide you a small XML snippet you can paste into your Log4j configuration, and as soon as you restart your app, it starts sending your logs to the server, and you see on their dashboard, you see your logs appearing, and you can start defining alerts and all kinds of things, and it's all taken care of. So that's these are very good solutions available today. Now, dealing with sessions is another thing, because if the session is living in RAM on your instance and the instance goes, the session is usually gone as well. And we've had all kinds of bad ideas in this space for the JVM, where we kind of started working with sticky sessions and trying to remember the load balancer, but then it takes a long time before you can decommission an instance, because even if you drain your sessions and you're only for remaining customers, somebody gets in the office at 8 o'clock, starts working, and that session could survive 8, 9, 10 hours. So it takes a long time before all sessions are drained. So that's complicated. Then we've looked at things like clustering and being able to share and replicate the sessions between nodes. But then we found that as soon as we get more than a few nodes, we need to start doing peer election to avoid too much network traffic between the nodes. And so eventually just a whole bunch of problems. And don't even get me started about session timeouts, which are just horrible for the user, but are there to avoid basically our RAM on our server filling up with all possible sessions. So at some point we want some algorithm to evict it, so usually time-based, and then we kind of throw them out. And the solution is actually to look a bit around at what other platforms have been doing. The Rails guys have been doing this from the start. The Play guys are doing this now. ASP.NET has been doing this for a long time. It's basically to say, we don't want the session in RAM on the server, we're going to push it out to the cookie. Now, we can do this in a way that is secure by having cookies that are cryptographically signed and are encrypted. So you have the stuff on there, you prevent tampering, and you prevent it from being read by the wrong eyes. So what does this buy us? No more session timeouts, because all of a sudden, you do not need to worry about all the sessions that are currently open. You can start really sizing your machines according to the number of requests you're processing in parallel, not to the number of open sessions. So that's a big change there. No more clustering, session replication, and all these horrible things. No more sticky session. That's all gone with a very simple change to have your session in the cookie. For the JVM, there are very nice solutions. There is an open source project on GitHub. Just kind of Google stateless session Java. You'll find it, and it's basically just a servlet filter. And what you do is basically you stick it in front of your application so that when you send out a response, it will take your session object in memory, serialize it, sign it, encrypt it, add it to the cookie header, send it out to the client. The client on the next request sends the cookie back, just an HTTP header, encrypted, cannot see what it is, but just sends it back. And on the server side, what happens? The filter sees it, decrypts it, verifies the signature, recreates the object tree, and then from within your application code, you can just access request.getSession and start working with it again without seeing any difference. And you've solved all these other problems. Very easy and very efficient. Now,
I'm sorry about sessions. So,
sure.
What about just keeping them in the database?
That's another option. So you can. The important thing is really to have them out of the instance. So there is no exclusive knowledge on one instance. Now you then have two choices: move them towards the front, to the cookie, or towards the back, database, in memory cache, whatever you want to use there. So for me, that's definitely a possibility as well. You then have to manage the storage for all that and deal with these things, but that's a good second choice. I would say the first choice should be the cookie. So if you encrypt it with AES 128.256, to the best of our knowledge as an industry, we have 30, 40 years of security with that. So of course, what is important here is that the secret you're guarding has a lifetime that is shorter than the expected lifetime of the security of the cryptography. So if you feel that your user ID of what you stick in there should live longer than 30 years or 40 years, then maybe it's not a good idea, and going towards the backend is a better thing. But if you think it won't live that long, then I would recommend this solution first, and only if you have good reasons not to use that, and go towards the back, because the database is actually very fast these days. RAM is cheap. I'm a big fan of the provocative comment a guy named Clay Shirky made a few years ago. He basically had this comment: algorithms are for people who don't know how to buy RAM. And of course, I'm stretching the truth a bit, but there's a lot of truth to that for databases these days, where half a terabyte of RAM is actually reasonably cheap these days. And you can keep your databases, many types of databases, just in memory, so that only your writes touch disk and all the reads are handled exclusively in RAM. Combined with 10 gigabit Ethernet, it's actually very fast. So that's definitely a very viable option as well. So rolling out new versions, we already saw a little bit of that during the demo. So how does that work? And we've got our existing version of our app. We've got our load balancers sending in a request, forwarded to the app, sent to the database server, kind of processes it, sends an answer. Now, where is our app living? In the cloud. It's living in something called an availability zone. You can think of it as one or more data centers in one geographic location. And if you want it redundant, you have multiple availability zones, so you deploy it twice. What this usually is data center on one side of a city and data center on another side of a city. So they're far enough apart that they're basically, if there's a power outage on the one side or a flooding on the other, then the other one usually stays up. If you have a nuclear bomb dropping there, you probably have bigger problems than your application being up. So that's something that shouldn't worry too much about. we ship our logs, of course, to our log server, and we have our session in the cookie. So what happens? Fire up our new app, blue-green deployment. We do not want to interrupt service. The existing application keeps on serving requests. We fire up the new one, make sure it's healthy. Once it's healthy, we start serving traffic towards it. If that's working well, we start stopping serving traffic to the old one, decommission the old one, done. Very smooth, zero downtime, blue-green transition. The elephant in the room is, of course, what about OS-level virtualization? What about containers? To be able to answer that question, we have to look at modern CPUs and how they work. Since 2006, all major CPU vendors, AMD, Intel, have started support at the hardware level for virtualization. So what this has brought us is isolation between the different guests running on a machine where you really have, at the hardware level, a protection so that they cannot influence each other. Now, this has a certain cost as far as performance is concerned. So every subsequent generation of CPUs has added new instructions to reduce this cost by making it easier to traverse the memory, to go to the network, to do I/O in a more efficient way from within a VM. So that today we are in a world where Xen or KVM are within 2 to 5% of bare metal, but there is still a cost. Now, remember our Edison screw. For me, this could be a little bit like a universal adapter for multiple Edison screws on one CPU. So if we have our stack here, and where we have our hardware, our hypervisor, our bootable app, or classic OS stack, it doesn't really matter. The blue line here is really the isolation at the hardware level, where the CPU is basically isolating that from the rest. And if we have OS-level virtualization, this is what we have here. We have our hardware with our base operating system and container runtime, and then bootable app or a classic OS stack on top of that. So if we are on-prem, the big difference here, of course, is we do not have the blue line, so we do not have the performance penalty of that. So when is which of these interesting? You have to look at how your workload is basically divided. If you have a very homogeneous workload, everything on Linux can run on the same version of the kernel, this is probably the right choice, because then you have a very low overhead. Of course, you have some things you don't have, like you don't have live migration at this point, and a number of facilities that are available in the VM world, but other than that, it's actually quite a good solution. If you look at this side here, this is when you have a heterogeneous workload. You may have some things on Windows or that are only certified to run on certain specific Linux distributions. All the way to the bottom, it's only certified to run on Red Hat version such and such or whatever. So that is then something to consider there. Now, if we bring the cloud into the mix, this is what it looks like. We've got our hardware, our hypervisor, and if we run with OS-level virtualization, every single provider today works like this. You have your own pool of instances, and then you have your base OS plus your container runtime, and then within that pool, you can then schedule your containers, and whether they contain bootable apps or classic operating system stacks, that doesn't matter, and you schedule it within that. So the reason you have that, of course, is that here, you cannot trust your neighbor anymore. It could be that you have a competitor on the same physical machine that is trying to sabotage or Trojanize you, so you need the isolation at the hardware level to make sure you don't run into trouble. But the thing you have here, of course, is that all the nice things that we're taking away from you, all the capacity planning and making sure that's all kind of running smoothly for you as part of the control plane, is stuff you now need to run yourself again. You kind of bring in a separate control plane under your responsibility, because this is basically the responsibility of the cloud provider. That's your responsibility. And in your side of things, you now bring a second control plane. You start to have to manage, you have to think in advance how many instances you need in your pool to schedule all your containers you've got running on that. So it's a decision to make. And how to make that decision should really be based on the granularity of your budget. So the most expensive way to run an instance is on demand. And so a 1 gigabyte T2 micro instance on AWS currently costs $9.60 a month. That is the most expensive you'll ever pay. If you reserve it, you run well below that at maybe 60, 70% of the cost. So you're at $6, $7 for something like that, which converted is about 1.3 US cents an hour, or well under 1 cent an hour, if you reserve it. So the question there is, can your budget afford 1 cent an hour at granularity? If the answer is no, then you should put in the effort and further subdivide the instance to be more efficient. If the answer is yes, then why bother with all these problems? Who cares if some instances may have a few hundred megs of RAM available? Not your problem. What you care about is your budget and how these things work. And so that should be the question driving your decisions there. So if we summarize, we've taken the principles we've learned to enjoy at the application level, where we have, as part of our build pipeline, we produce one immutable unit after every commit, and we regenerate it after every change, so that we then promote it from environment to environment to avoid the classic mistake of building a separate artifact per environment, because of course we want to run in production the same artifact we tested in test. And we apply all these principles by trimming the fat and bringing them to the level of the entire system. Now, these ideas, of course, you're more than welcome to implement them yourself. I strongly believe in them. And if you are on the JVM, and if you are running on AWS, of course, I encourage you to have a look at what we're doing as well at boxfuse.com. So we have a free tier that maps perfectly to the AWS free tier. So it's basically zero to run one instance on T2 Micro and have all that there. So if you're interested, please have a look and get in touch. Yes?
I was having a question. Your solution works only with Java?
At this point, it runs JVM apps just because we had to start somewhere. It's not limited to Java, the language, so you're free to use JRuby, Groovy, Scala, whatever you want to use on top of that. Our plan is to support new different platforms soon. So the next candidate will probably be Node, and then we'll kind of expand from there. But that's the current state of affairs. So right now it's JVM-based apps, and if you are on WebLogic or WebSphere, we probably cannot help you either. But if you're on a modern lightweight solution, then it works really well. And that's all I have for today. So here's my my Twitter account as well if you want a shout out. Otherwise, feel free to get in touch, and thank you very much.
Can you explain the differences between boxfuse and Flynn or Days?
Well, they went down the pass route with the Docker containers. I think we'll see how that all play out. I personally believe that AWS is a very strong player in the market, and they've got some very good things going. So we decided to go down that route and trust that path. We'll see where Flynn and Days and running their own paths will go. I think that the jury is still out for that. I must say I see the use case for running your own paths and having your own infrastructure evaporating rapidly. I think it will become harder and harder to compete with the public cloud, simply economies of scale of what's being offered there, just because they have so much muscle right now with just the dedicated hardware. They're getting conditions on the market you can never compete with as an organization. But of course, due to regulatory requirements, if you're into banking, healthcare, and all that, for a long time you will be stuck on your own hardware. So we'll see how the market shares will evolve.
If Google, for example, exposes Kubernetes to the outside, it's the same thing as Amazon is doing for the.
Well, they are doing part of that with their. If Google exposes Kubernetes to the outside, it's the same thing. Well, we'll see. And there's a lot of shared concepts, of course, but we'll see in the compute engine. They have similar things on the go right now. We'll see how it plays out. But right now, there's nobody that is exposing the containers out there without having the fencing at the VM level. So we'll see how that will evolve, and I think right now also we'll see how the whole minimal OS type of images like we are doing is evolving and how things will go. So the jury is still out. I will say it's interesting and exciting times anyway to be in. So that's a good part. Yes.
You mentioned that one of the main ideas is this: you have one immutable unit that you can then deploy to different parts. If you have an application that really wants to differentiate between, really wants to run on different nodes and to communicate between these nodes, so an application that wants different images, so to say, for different machines, is this something that you've thought of, or is it something, it's a direction where you don't want to go? This could allow, for example, if you deploy different functionalities of a larger app on different nodes, it would be more flexible because you could update parts of it without really touching the others. But of course, it brings you the configuration and the synchronization between those. So there's a
just going to repeat for the video. The question is, what if you have a larger app and you want to deploy it on different nodes, but you want these nodes to be configured differently, so this functionality is available there but not here, and how do you deal with that? Well, there's two ways to solve it. If it's configuration, you can of course deploy the whole thing, pass key value pairs, and just kind of enable that bit or that bit depending on the environment or the machine you're on. The other question you should ask, of course, is if the lifetime of these various components, if the life cycle is slightly different, would a physical partition between them make more sense? And would you like two separate services? Maybe instead it's a decision to make to evaluate. But yeah, so this is how we would solve that part. Now, if different nodes as part of one environment must know of each other and kind of know where they are, nothing rules out classic solutions like using console or some other classic thing where you kind of delegate the service discovery onto the individual nodes, and they can then kind of query the central repository and kind of figure all that out. So that's still possible as before. No change there. Yes.
If you have like multiple application stacks, can you orchestrate all the images from those application stacks to multiple servers based on a criteria or something like that?
So if you have multiple application stacks, can you orchestrate all these deployments from these different stacks to multiple servers? At this point, we don't have anything like that. So you can basically trigger the deployment of one application and roll that out, and then you can do the next one. You can of course write a batch file that does different ones. That's of course possible, but out of the box we don't have support for that right now. It is something we're looking at in the future, having some kind of dependency mechanism between services where you can say this guy needs that guy and that guy and that guy, and if they're not up yet, just kind of bring them all up as well. But not there today.
And also the rollback if an image is not performing well.
So how do you deal with rollback if you're unsatisfied with the version you just deployed? So there's two things there. So the first thing that's happening is that all deployments, first of all, are transactional. So if you deploy something and the health check fails while it's coming up, it's kind of killing the deployment. Because it's blue-green, the other part is always running, so you're serving the traffic and not interrupting anything there. If you discover at the later date that you're not satisfied after 2 days of service with the app, you can simply redeploy the old version. So they're all stored in the Boxuse Vault online. You can just kind of pull the old version and they'll just kind of redeploy it with zero downtime, blue-green, and be done with it. Okay, yes?
Secure idea is based about you have minimum of 2 sites to be available in order to be able to deploy different versions of the application. So you can't work with one site.
Well, so the question is, in the small demo there, we had a minimum 2 sites for the availability. Can you work with just one site? Just for me to clarify, which site do you mean availability zone?
No, not availability site. I mean, you want to keep your application up until your deployment is finished. Okay. After that, you switch.
Okay, so you mean 2 instances. We have 1 instance, and then you bring up the second one, and can you do it just with 1 instance? So at this point, no, and it is also not something we plan on changing in the future, because we actually like the fact that you don't kill the existing instance until the new one has proven to be healthy. And the additional cost is actually very limited, because for this transition period, even if you have 10 instances of your app and you temporarily fire up 10 more for the new version, well, you have an extra cost of something like 20 cents or €1 for that hour. So it's very easy, and then you can shut down the 10 old ones and done. So what you get as benefits from it for us outweigh the downsides, and so we have no plans on changing that.
Okay. Given your experience also with Flyway, how you handle the situation with database schema change during this deployment, which required some changes at the database level?
So how do you deal with database upgrades in this case? I think for me the secret there to doing something smooth like that is to produce or to write backwards compatible database migrations down to the last version that is currently in production. So hopefully it's just 2 versions you need to support, the old and the new one. Could be more, but hopefully just 2. And you basically always apply the same model. This is basically just universal technique you can use for everything. It's expand and contract. So you basically expand your interface and you contract it. In this case, the interface is the database schema. So you expand it to support the new version of the app and the old version. And then once the new version has proven to be successful, you contract it again in the follow-up version by removing the temporary structures that were still supporting the old version, and you're left with just the new stuff. And this is something you can apply for everything. Whether you have REST services, web services, APIs, it's a deprecation period where you go from A to A plus B to B. And that's a very powerful thing for decoupling also rollouts of applications. And because I think we all know that the Saturday night disastrous rollout where you kind of need to roll out 5 applications, number 5 fails, but they only work together in the new version, so you need to roll all of them back to have a system that's okay. Well, that's something you can eliminate there as well by using expand and contract, by basically having all your applications temporarily supporting the old and the new version of the different ones they talk about, and then you can they talk to, and then you can decouple the release cycles there as well. And the same applies here. So if you have your database, you migrate it, it's backwards compatible, so the old version can keep on serving traffic. The new version, let's say, is not fit. There's a problem with it, so you just kill it. The old version keeps on working. You now have some unused structures in your database, but that doesn't matter. What matters is keep on serving the customer as being available with the service, and that you've guaranteed. So what you do basically is you have to put a little bit more thought into it beforehand, and then you get a lot more comfort in production later.
So it is more application logic, not.
No, it's actually in the database, because the database is the interface and it supports old and new from the application. But the way you can do this, right? For example, if you rename a column, you would do a one-time copy of the column and introduce a temporary trigger that kind of synchronizes all the new column, and then when you get to the new version, so to speak, you can discard the old column, discard the trigger, and all the stuff in between, and you transition like that. All that is described in a book called Refactoring Databases. It's about 12, 13 years old, from the Signature series of Martin Fowler, you know, the Addison Wesley books, black and red. And there are 2 sections. The tooling section is outdated, but the section about the techniques for these type of migrations is still very, very relevant. And so you can just follow the recipes. And so in the beginning, it seems complicated, but after it's just automatic. It's always the same types of steps for the same types of transitions. And that makes it very easy.
Thank you.
Yes?
About the bootable app, I have a question. As I understood, you used something like a microkernel for Xen, for example, like Mirage OS.
Well, so the bootable app here, does it use something like Mirage or?
Actually, the question if you can put it over a hypervisor type 1, I think, over the bare metal. Well, in a sense, it's running on type 1 on AWS, because AWS is Xen, but we don't use anything like Mirage does. So they basically have just a single address space where everything's combined.
compiled together. We have a bit of an intermediate model where it's basically just standard off-the-shelf components. We kind of stick together, so it's a standard Linux kernel, very tight configuration, very small, just for what we need. But it's standard Linux kernels, standard C libraries, standard OpenJDK, and standard Tomcat, for example, in what we had here. So it's not all combined in one big binary like these guys are doing. But on the other hand, yeah, it's also a pragmatic, tried and true way. So both advantages and disadvantages. Yes.
How do you compare box fuse to something like Chef or something which you can already build? So box fuse is something ready to use, like easy to configure, but Chef requires some skills to be able to do the same thing, provisioning, bringing all dependencies and deploying. Okay, I mean, why I have to use box fuse and not to build my own Chef recipes?
All right. So the question is, what if box fuse is easy and Chef is hard and requires effort and knowledge? Why should I go for the easy way when I can do it hard?
For sure, something is easy to use. I think is limited.
Absolutely, so it's opinionated. It's not universally applicable. It's applicable to a more narrow field. And in this case, our 12-factor microservice modern apps, and for them there is a fantastic integration. But it doesn't have the breadth of field and the universally applicable space that you would have for other configuration management tools today. So you need to kind of find and see if you fit into that narrow use case. Then it's probably a better choice for you than the general purpose solution. But if you don't fit into it, the general purpose solution is probably a better one for you today. So that's for you to see where you kind of fit in that spectrum, and of course how many what type of skills you already have within the project or the organization and what you want to build up.
Management of box fuse is done only through command line or API, or do you have a web interface? Or
so the management, is it just done through the CLI, or do we have a web interface? We have a web console as well, where you can see your different apps. Just gonna pull it up here. Yeah, so here it is. For example, that's our app. Here we see the last version we deployed, and then you can kind of scale your apps from there also and do all that. So we've got both actually. We've got the CLI and the console there.
The web management, it's only SaaS, or it can be on premise?
So for this year, it's only SaaS, just because that's where the early adopters are. But on-premise is something we're considering for the future. Just probably coupled with a VMware ESX type of workflow, or we'll see. I think this is something we're going to look at maybe next year. I think this year our focus.
How do you deal with the security in terms of assuring people that the images are secure and all data?
So how do we deal with security? So all our we have a repository of components comparable to an apt-get repository or remote Maven repository. All that is we add new components by building fresh images from nothing, from scratch. Inside these images, we pull the sources from the original source repositories. We build them, and then we upload them via SSL. The artifacts in our remote repository there. All communication amongst the different nodes, amongst the client and all the parties, is always encrypted with SSL. Your images are client-side encrypted with AES and are stored encrypted in the cloud. So there's and the key is not together with the image, so it's spread out like that. So these are the different measures we use. So there is never an encrypted communication between the two, and we always take a clean room system when we feed new artifacts in the system.
And if you have service interruption, the images will be affected on AWS?
So if for example, our console goes down, do we have...
the repository.
Or if the repository goes down, will my app that's currently running on AWS also have a problem? No, it's strictly separate. because this is really our separation between control plane and data plane. So this would mean we have an issue in the control plane, and building all that, the data plane where the stuff is running is unaffected. Yes?
You mentioned microservices a couple of times.
Yes.
How does BoxFuse solve the problem of service discovery? Because one of the main principles behind microservices is for them to be able to talk to each other.
Yes.
So if I deploy one set of microservices on one box and another set on a different, how do they find each other?
Well, we briefly, so how do we solve service discovery? If I go back to the slides, we had the slide there where we talked about it. Just let me go. Up. It's exciting. All the animations backwards. And there's a lot of them. Sorry. Here we are. So this is really the clue. Using a stable entry point with an internal registry. Now, this entry point we use in the demo as an elastic IP, and the registry is internal to AWS, where it kind of keeps track of which backend instance is connected to the elastic IP. If you want more than one instance, you want to front that with an elastic load balancer. And the elastic load balancer has a fixed address, so you can always point at it. And which backend instances are currently up is not your problem. That's the elastic load balancer's problem, and it will figure out how to forward the request for you there. You, as a service, only have to remember the address of the elastic load balancer of the other service, and the rest taken care of. You don't care if there is now 1 or 10 instances running, if it's the same instances as yesterday or not your problem.
Then this does not work for a multi-level architecture, right? I mean, if you have something behind that bootable app, how do you differentiate or how do you discriminate between the types of?
So how does this work for multi-level architectures if this guy would require other services and other things? Exactly the same thing. Put another elastic load balancer in front, do the same thing. Okay. It doesn't have to go all through this load balancer again. You can have multiple load balancers. Some of them can be internet facing, other of them can be internal within your architecture. Yes?
The base operating system is Debian or Debian based?
Sorry?
The machine is Debian based?
Oh, is the machine or that we generate Debian based? No, there is no basic, there's no base image, no base distribution. We start from nothing, and we basically pick the components we need, throw them together, done. So there is no Ubuntu, no Debian, no Red Hat, no nothing. Yeah, we then put in the bootloader, the kernel, the different things, and just kind of steer 3 times and hope.
Actually, it's BoxFuse distribution.
Yeah, well, in a sense, it's a very, very tiny distribution, but it's always dynamic based on what you have in. So we kind of you configure the components that they can put in exactly that way. We automatically generate an intelligent start script requiring exactly what you want for your application. Done. So there is there's no 2 images in a sense that are the same like that, because based on what you put in, we'll have then just a different output. You never have something redundant.
You also have a builds process inside BoxFuse, or do you use something like Jenkins or Ansible or something?
So your question is, where are the images built?
Yeah, how are they built, and how is the application being built and configured?
Well, so how the application was built that we saw with Maven, just clean install. We got the jar of the WAR file.
That was with Maven. Okay.
And then you can feed whatever, you use whatever tool you want, but you then I give a WAR file or a jar file. That's what we support at the moment. And then from there on, it's on your machine. So what happened there was also on my laptop. What you saw in these 10 seconds, my laptop's running Windows. You can be running on Mac or on Linux. It doesn't matter. It works on all platforms. And basically client side, it's then generated. So if some dependencies are missing, some components, it'll pull them from the central repository and then just kind of all assemble them there. So it's all local on your machine.
You mentioned that FuseBox doesn't support commercial application servers, only open source. But does it support a full enterprise application server like JBoss?
Well, so the question is, it doesn't support commercial application servers and
WebLogic,
but like WebLogic or WebSphere, but does it support JBoss? The answer there is it will soon automatically, because Wildfly is now also moving into the direction of having embedded containers and being able to package it like that. So that's what they're doing with the newest version now, with version 9. And so once it's there, no problem. There is no inherent restriction. If you just then package it as a Java file, that's it. Why don't we have support right now for WebLogic, for WebSphere, or for classic JBoss? It's just because they're complex beasts with all the XML files and all the configuration, and something where the companies that usually run WebLogic or WebSphere right now are not the early adopters we would have as customers today. So for us, it's not a valuable return on investment to invest a disproportionate amount of effort to support something that nobody may need now. Yes?
How does BoxFuse compare to HashiCorp's Packer?
Well, Packer basically will then again, and Packer will build your machine image for you based on some kind of provisioning. It will build it on different providers for you, but it basically rebuilds. If you want to have the same machine running on VirtualBox and on AWS, it will try to rebuild two machines identical to each other. So it will run the process twice. Whereas here we don't have that. We really have one machine, and that's being transported unchanged from one on the other. The other difference, of course, is that there is, again, the general versus specific solution. So we have a specific solution with very deep integration, whereas they have a much more general solution there. So for example, what we have is we have DropWizard integration there. We know how to read the configuration files of DropWizard, know where how to pick out the URLs, where the health checks are done, and the ports, and it's all configured automatically for you. Whereas a general tool like that will not do that, but can package other things that we cannot. So, so again, depends where you are and what works for you. All right. If there are no more questions, oh, sorry, didn't see.
Is the infrastructure as code hard coded in the product, meaning that I can choose, for example, the type of the instances if I want spot instances on Amazon or?
So how can you choose the type of instance on Amazon, or how is that right now? So at this point, there is no explicit support for spot instances, but the AMI gets created on your account. So even if we don't support spot instances right now, you are free to use the AMI as you wish with spot instances today. We may add support in the future because it's definitely something we're looking at, because you can save a lot of money with spot. So it's a very interesting model. But right now you have to take the AMI and then work with it from there. But you can still have the AMI, because what we wanted was to have a standard input format and a standard output format. We didn't want you to have any lock-in. So have a standard application come in, a standard AMI come out. And if you're not satisfied one day anymore with BoxFuse, rip it out, replace it with Packer or something else that does the same job for you, and you're good to go again. All right, I think it's probably beer o'clock. I think we're all happy with a good evening. So thank you very, very much.
Thank you very much, Axel. Usually after our meetings, we end up in some bar nearby and talking some random stuff. Axel, maybe if you can join us, or or anybody who can stay after this, is invited. Thank you very much for your presence.